Hello and welcome back to M17 Labs Poland. I'm Wojciech Sierra Papa 5, Whiskey Papa, and today I will be showing you the common amateur radio interface. So let's get started. Let's take a look at the block diagram. If you haven't seen our previous video, it would be very wise to do that now before you continue. So we've got the baseband unit and the remote radio unit, and they are both connected over optical fiber. We've got the baseband unit at one side and the remote radio unit at the other side of the connection. The CARI protocol can be used for baseband transfer and control. The baseband transfer is probably self-explanatory. We send baseband samples from the baseband unit to the remote radio unit and vice versa. So when we want to transmit, we obviously have to send baseband samples from the baseband unit to the radio. And for reception, of course, we do that the other way. So we send the baseband samples down the baseband downlink to the baseband unit for processing. Now the control. To set all the parameters of the transceiver, we have to dedicate a control plane for the CARI, and that's the RRU control. So that carries all the control commands over the transceiver. So for example, that's setting all the frequencies, setting the transmitter power, automatic frequency control for the receiver, and so on. And last but not least, we've got the feedback channel for telemetry data, and that channel carries temperature of the chassis and the reflected power, and also the incident power if we want to use that information too at the baseband unit level. The CARI is based on 0MQ. So for the baseband uplink, we've got a publisher that publishes the data in chunks, and the subscriber at the remote radio unit collects the data and uses that to modulate either IQ transmitter or FM transmitter. In our case, we've got CC1200 in our remote radio units, so that means we don't have IQ access, and we can only transmit FM right now. So all of the baseband that goes to the CC1200 is being frequency modulated and output at the RF output connector. Then we've got baseband downlink. We've got another CC1200 that is configured as a receiver, and that receiver gives off baseband samples at 24 kilohertz, and those samples are transmitted over baseband downlink channel using a publisher at the remote radio unit side. So at that side, we've got the publisher and subscriber that collects the data from the remote radio unit. Then we've got a request and reply pair for the remote radio unit control. That is used for sending commands and receiving acknowledgements that the command has been received correct and is being executed. Then for the feedback, that's the same story. We've got a publisher that constantly publishes the data that is collected by the telemetry block, and the subscriber at the baseband unit collects the data for further processing by the CPU. Moving on, let's take a look at the command set offered by the CARI. The command consists of three things. The first byte of the command is the command ID. Then we've got the byte count, that's 2 bytes. The remaining bytes are the parameters for the command. This is the command list that is available on GitHub, so you can take a look at it yourself later on. I am going to put the link to this in the description below, so don't worry. We've got quite a few commands for the remote radio unit, starting with the ping pong command. That's used to probe if the remote radio unit is actually alive and accepting CARI commands. The command sent to the remote radio unit from the baseband unit is just 3 bytes, and the response is 7 bytes because it carries the command ID, which is 0, then byte count, which is 7, and then parameters. As the parameter, it takes a 32-bit value showing all the errors if there are any. Normally the response should be 0, so if there's any error we can just set any flag that we want to signal that something is wrong at the remote radio unit. Like, for example, the phase locked loop doesn't lock in either the transmitter or receiver. So we can signal that using one of the flags in that field. Then we've got set RX and set TX frequency. That's a 64-bit field for setting the VCOs in the remote radio unit. Originally we had 32-bit fields for that, but since that only gives us like 4 GHz of range, we decided to go further and expand that field to 64 bits. The next command is set TX power, and it takes 8-bit value unsigned as the input, and that is the power in dBms multiplied by 4. So if we want to transmit at 30 dBms, we have to set that field to 120. Then next one is reserved. It was used previously, but I have removed it, and now it's reserved. Then we've got RX frequency and TX frequency correction in ppm. Then we've got automatic frequency control, AFC for short. That's used with the CC1200 because that IC supports AFC, so we can use it. So let's do it. Then another reserved command. Then we've got reception stop and start. This command can be used to start and stop baseband transmission over the baseband channel. So if you look at this block diagram, we can start and stop the baseband downlink happening here. The next command is 0MQ subscriber connect to publisher, and that command is used to connect to the baseband unit. The parameter is the IP address. This command points the remote radio unit to the baseband unit so that it knows where to fetch the baseband samples from for the uplink. The next command is stream chunk. That's only used between the interface board and the remote radio unit. So this is what I've told you before, that between the remote radio unit and the baseband unit, we use the reduced set CARI interface, because this command cannot be used between the remote radio unit and the BBU. This command is only supposed to be used between the interface board within the remote radio unit and the RF board. This carries the baseband chunk that fills the FIFO in the RRU for transmission, and vice versa. The remote radio unit, when the buffer is full, it transmits the baseband as a stream chunk to the interface board for further processing. In this case, that would be just pushing the baseband samples down the CARI, down the baseband unit. Then we've got read commands. We can use CARI to read different kind of information from the remote radio unit, like the ident string, that's telling the baseband unit what device is actually connected over CARI. Then we've got devices capabilities, like frequency range, power range, and so on, and also modulations that are supported by the RF board. Then we've got RX and TX frequencies. Then we've got the TX power, and encoding is the same. Next, that's the RX and TX frequency correction as ppm. And that's it. That's the command set for the CARI, and it allows for baseband transfer control over the device. And the remote radio unit that I have on my desk only supports M17 and FM for now. Soon, I think I'm going to replace the CC1200 with SX1255 chips, and those are complete IQ transceivers, and that should allow them to transmit and receive all modes, not only M17, but also Tetra and higher order modulations like 64 QAM. But for now, we are going to stick with FM, analog FM, and M17.